Hello, today I'm gonna do my not my do chem equilibrium equilibrium systems again because it's not big. It's like a difficult topic. Yeah. First question says Ag2CrO4 is a slightly soluble salt and forms a saturated solution. This can be represented by the following equation. 2Ag plus aqueous plus CrO4 2 minus aqueous is have equilibrium with Ag2CrO4 solid, where the change of heat is negative. Part A, predict the initial effect on the rate of the following reaction when the equilibrium is re-established after the following changes have been applied. Let's do that. So let me find it. Okay, yeah. So I says a few drops of concentrated NaCl solutions added to the system. So basically, what this do to the equation is that NaCl in water, okay, in aqueous solution would disassociate, and the Cl would bind to the Ag, and then those will not be participating. Oh my god, participating in the equation anymore, which means it's literally just a decrease of Ag. So basically, what that means is that because there's less things on the left hand side, the forward reaction will actually just slow down. And for the second one, the solution is diluted by the addition of small amounts of water. So adding small amount of water will decrease the concentration of everything, therefore slowing down all the reactions. So it will slow down again. For part 3 of this, the temperature is increased. The temperature increase, all the reactions speed up. That's literally how it works, because it's not about the concentration or anything. It's just the speed of reaction. So basically, it'll just speed up. Actually, yeah. Wait, if the temperature increase, the forward reaction should increase. But there is a change in heat, which is negative. That means that it's exothermic. If it's exothermic, it should still increase. It should be increase or no effect. Or definitely not decrease. But yeah. Actually, it says after the equilibrium is re-established, after the following changes have been applied. The initial effects on the right. Okay, the initial effects definitely will be speeding up. So yeah. And then for part B, it says predict the effect on the concentration of G plus when the equilibrium is re-established after following changes have been applied. Part 1 says after a few drops of concentrated NaCl solutions added. That's literally what we just did in part A, which all that will do is decrease the concentration of Ag. So obviously it'll decrease, because that's literally what it's asking, like the concentration of Ag. Part 2 says same solid Ag2CrO3 is added to the system. Solid increase, it should mean that the reverse reaction is increased, but because it's a solid, it won't really change the concentration of the left hand side, so nothing will happen. Okay, so like no change. All right, no change. Part 3 says a temperature increase. Because the temperature increase, that means it doesn't, because it never increase, it won't want to be exothermic anymore. It wants to be endothermic. Because the forward reaction is exothermic, it wants to do the reverse reaction more. With more reverse reaction, Ag plus will increase. So when the temperature increase, the concentration will increase as well. And that's it for this question. And for the next question, it says when barium carbonate is when barium carbonate is heated, it decomposes into barium oxide and carbon dioxide. So the equation is here. Barium oxide and CO2 gas. Positive. Part A says predict the effect on the rate of the forward reaction during the following change. Barium carbonate is ground up more finely. So more surface area, greater rate of reaction. So it's just a greater rate of reaction, so it will speed up. And for part B, not for part B, this is part 1. Part 2 says the system is cooled. When systems are cooled, it will obviously slow down the reactions. Slow down. For part 3, it says CO2 is removed. So basically, when CO2 is removed, then there is not a lot of not a lot of reverse reaction, therefore not a lot of forward reaction, because it's just a decrease of things. There's decrease. It will actually speed up the reverse reaction, but which means that the forward reaction is slowed down. Wait, no, it says removed. The removed means it should speed. Okay, yeah, but even if it's slowed down, the effect, the total effect on the rate of forward reaction will still be slowing down because you're removing you're removing like all the gas, which is part of the reaction. So less reaction will actually happen. So it will slow down. And for part B, part 1 says predict the effect on concentration of carbon dioxide when equilibrium is re-established during the following changes. More barium carbonate is added. When more barium carbonate is added, because it's a solid again, nothing really happens to the concentration of the gas, so nothing happens. No change. No change. And for part 2, it says the volume is doubled. When the volume is doubled, that just means the pressure is lowered, but that doesn't really help in this context. So volumes doubled, that just means the particles have less of a chance to interact with each other because there's more space, so they can hit other empty space other than hitting other particles more. So basically, what that would do is just it would mean that wait, let me think. Because even if the volume is doubled, barium oxide and carbon dioxide still have more things, so they will still interact more, which means the reverse reaction will be fast, and which means carbon dioxide will decrease, the concentration will decrease. It's mainly because the area is doubled. Well, the barium carbonate will be harder to do the forward reaction. And for part 3 of this question, it says the temperature is increased. Because the temperature is increased, it wants a endothermic reaction. Endothermic reaction ends up with a positive change of heat, which is the forward reaction. Forward reaction will result in more concentration of carbon dioxide, so it will obviously increase for carbon dioxide concentration. That's it for the questions. Oh well, bye bye.